Alright, B and C. So Kelsey, you asked about question 4, right? B and C. Can you tell us about question 4A? So you go inside the for loop, right? How many times? How many times? N times? So n minus 1 times. Alright? So which means that if you are tracking the number of additions here, right? How many times will you do it? So the number of additions is n minus 1. Okay, alright, yeah, that's correct, n minus 1. Then what is the big O? Okay, alright. Now we're going to do the same thing for 4B then. So for 4B, we're going to see how many additions we are going to do. So let's unroll the I, right? Now the I here, what is the range of I? So what are the values that you can take? One, two. So if the range there says 1 to n, so what does it mean? It means that the last one is excluded, right? This is the Python syntax. So you're going to go from 1 to n minus 1, alright? So when I equals to 1, how many additions do you need to do? So there are 2 additions here, right? So 1, 2, and then you need to call on fi, right? So there is the 2 additions here, and then you need to call f1. So when I equals to 2, 2, and then you need to call f2. So this is 2, you need to call f3. This is 2, you call f4. Finally you have 2, then you call fn minus 1. Now when you call f1, how many additions do you need to do? When you call f1, you call this one, right? So then you come inside, the range is from 1 to 1. Do you go in or not? No. So that is a 0. So you just return, right? So f2. How many additions do you need to do? 1. f3. 2. f4. Right? How about fn minus 1? So n minus 2, right? So these are all the total number of additions that we need to do. So we just need to add them up. So you have 2 plus 2 plus 2 plus 2, n minus 1 times. So how many additions do you have here? So you have 2 here, 2, 2, 2, 2, right? So we come from 1 to n minus 1. So this one is going to be 2n minus 1. Now how about the addition here from 0 to n minus 2? So we will do the pairing thing, right? So 0 to n minus 2. So that's n minus 2. 1 to n minus 3, which is the one before, is still n minus 2. Now how many pairs are there? We are counting from 0 to n minus 2. So there are n minus 1 numbers, which means there are n minus 1 over 2 pairs. So then this is the total number. Then we just need to simplify this. This is 2n minus 2 plus n squared over 2 minus 3n over 2 plus 1. So then it's n squared over 2 minus n minus 1. So then the big O is O n squared. Yes.
Maybe just use the big N.
Can you just the?
Can you use the big N from A to cos A?
All right. Can you say that again? So what do you mean by just use it? Yeah.
Can we just use the big O that we gotten from previously?
So what do you mean by use it? How do you use it?
It's like you just multiply by the N.
So you're saying because this one is ON and you keep repeating it. Now in this particular case, that will be correct, right? But I think the point that I'm trying to get to you is that you actually need to look at the algorithm and you need to look at the runtime, because you cannot be sure that that is exactly the only thing that it's actually doing. So I think there are a couple of points here. The first point is that you need to look into any other method that your method is calling, because the complexity of the other method is going to affect your complexity. And the second thing is, as much as you can, try to analyze your algorithm, try to unroll it so that you actually understand what's going on. Because in some sense, most of the time, maybe about half the time or 2/3 of the time, what you're saying will work. Just look at the number of for loops. Just look at whether it's calling some methods. But you know, it's not going to cover all the cases.
But if the function is a black box, then you can just use the
If the function is a black box, then you open up the box. Then you got to figure out what is inside the black box, if you really want to know the complexity. Because otherwise, there is no way to tell what is going to be the complexity of the algorithm. Yeah.
Plus n over 2, right?
Which one?
N squared over 2 plus
n squared over 2 plus n
n.
over 2. That's right, yes. All right, thank you. Yes. All right, then we go on to the final one. The final one is the Hn. So the Hn is made up of Fn and Gn. And earlier, we know that Fn is going to do n minus 1 comparisons. That's additions. That's what we did for A. And for 4B, because we do Fn and then we do Gn, right? So that means we do whatever addition here and then whatever addition here. So we can add them up. So then this is coming from Fn. The one that's coming from Gn is the following, which is n squared over 2 plus n over 2 minus 1. So you just need to take the total sum of it. So the between n squared over 2 plus 3n over 2 minus 2. So it's still ON squared. Right? Because the 4C, we are just doing Fn and Gn in serial fashion. So one after another.